Hello friends, in today's question, a thin ring of mass 2 kg and radius 0.5 meter is rolling without slipping on a horizontal plane with a velocity 1 meter per second. A small ball of mass 0.1 kg moving with velocity 20 meter per second in the opposite direction hits the ring at a height of 0.75 meter and goes vertically up with the velocity of 10 meter per second. Immediately after the collision, so you have to check which of these following four options will be your correct one or which one will be false or true. So this is a bigger ball moving towards left with the speed of 1 meter per second, and there is a smaller ball which is moving with the velocity of 20 meter per second towards the right, strike at a height of 0.75 meter to the ring and goes vertically upward at a velocity of 10 meter per second after the collision. So let us first of all find out which of these options will be true, or we are going to start with option number A. And for this we are going to use the moment of conservation of angular momentum. So we can say, let us first of all find out the angular velocity of the ring before collision. Angular velocity of the ring before collision, and it is said that there is no slipping. So you can say, for no slipping, we can use the relationship that omega, that is the angular velocity, will be equal to linear velocity of center of mass divided by its radius. So velocity is given as 1 meter per second and radius is 0.5. We can say the angular velocity of the ring before the collision, that is omega, will be equal to 2 radian per second. Now let us start with the conservation of angular momentum. Conservation of angular momentum. So first of all, let's calculate the momentum before collision. So you can say before collision, now before collision we are going to find out the initial momentum, that is L initial. Okay, so before collision, let us suppose the angular momentum is given as N initial, and this initial momentum will be equal to the angular momentum because of the ring about the point of contact and angular momentum of the ball about the point of contact. There are some. So therefore we write the L initial will be equal to angular momentum of the ring plus angular momentum of the ball, and this is about the point of contact. Okay, about point of contact. So let us first of all find out the angular momentum of the ring. Angular momentum of the ring about point of contact, which is given as L ring, and this will be equal to mass velocity into radius plus moment of inertia of the ring and their angular velocity. And moment of inertia of the ring is, which is given as I ring. So we know moment of inertia of a ring, which is equal to I ring. This is given as mr square. So therefore, we can say that our moment of inertia, angular momentum will be equal to mvr plus mr square multiplied by omega. So we found out the first part. Now we are going to find out the angular momentum of the ball about the point of contact. Angular momentum of the ball about point of contact, and that is given as L ball, and this will be equal to mass of the ball, velocity of the ball, and multiply by the perpendicular distance to the point of contact. Perpendicular distance to point of contact. So therefore, we get that L ball will be equal to mv ball multiplied by perpendicular distance. So therefore, we can write that our initial angular momentum, that is L initial, will be equal to, we have our mvr plus mr square multiplied by omega plus mv ball multiplied by perpendicular distance. Substituting the values, mass of the ring is given as 2 kg, its velocity is given as 1, radius is 0.5 plus, and this will be once again 2 multiplied by 0.5 whole square, and omega, which we found out, is our 2 plus. Now comes the ball. The mass of the ball is given as 0.1 and velocity of the ball is given as 20, and perpendicular distance is 0.75. So therefore, we get that L initial is equal to 3.5. Now, after collision, now it is said that after collision the ball goes vertically upward. We say, since ball goes in vertically upward direction, its angular momentum contribution will be equal to 0. Upward direction, its angular momentum contribution about the point of contact, contribution about point of contact will be 0. So this is the regarding the ball. Now let us find out for the, you can say, ring also, and we assume that the new angular velocity of the ring is omega prime. New angular velocity of ring is equal to omega prime. Therefore, final angular momentum let us that given as L final, and L final will be only because of the ring part. So we get L final will be equal to mv prime is now the linear velocity of the center of mass, plus we get I ring and is omega prime, where this v prime is the linear velocity of center of mass after collision, obviously. Okay. So we substitute the values, we get that our L final mass is it's 2 kg, and we have v prime radius is 0.5, plus I ring is going to remain same, that is mr square. So we have 2 multiplied by 0.5 whole square, and we have omega prime. So from here we get that your L prime, sorry, not L prime, but L final will be equal to 2 v prime into this will be 5 by 10, and we have this plus 2 multiplied by this will be 0.5 multiplied by 0.5, or we can say 5 by 10 omega prime. So this goes by 5, 5 and 5 cancels, so this also goes by 5, and we get 5 cancel with 5. Okay. Therefore we can say that so from here we get this as L final will be equal to v prime plus 0.5 omega prime. Now using the conservation of angular momentum, conservation of angular momentum, we get L final will be equal to L initial, and our L final is v prime plus 0.5 omega prime, and L initial is equal to 3.5. Now considering the conservation of linear momentum, conservation of linear momentum, before collision, P initial will be equal to linear momentum of the ring minus linear momentum of the ball, and the mass of the ring is 2 kg, radius is velocity is 1 minus mass of the ball is given as 0.1 and velocity of the ball is given as 20. So this comes equal to 0. After collision, we have P final, and P final will be equal to mv prime. So conservation of momentum states that P initial will be equal to P final. So initial is equal to 0, so final mv prime. So from here we can say that v prime is equal to 0. And if v prime is equal to 0, then we can find out omega prime. Okay, let this be equation number 1. Say using equation 1, we get v prime is equal to 0, so we get 0 plus 0.5 omega prime is equal to 3.5, or omega prime is equal to 3.5 by 0.5, so this becomes equal to 35.5, and we can say that omega prime will be equal to 7 radian per second. So from here we can write that the linear velocity is equal to 0. Linear velocity is equal to 0, and the ring continues to rotate about the center of mass, which is stationary. So we can say about stationary center of mass, because v prime is equal to 0, we just found out. So it means statement A, which states that the ring has pure rotation about its center of mass, stationary center of mass. So statement A is true. So from here we can say that the ring has pure rotation about its stationary center of mass. Therefore, statement A is true. A is true. Now we come to the next part, which states that a ring comes to completely stop. Okay, but we just found out that whereas the center of mass comes to the stop, but the ring is still continuing to rotate. Okay, we just found out while the center of mass comes to rest, the ring continues to rotate. Therefore, we can say that statement B is false. B is false. Now we come to the next part, which is both C and D are related to the friction. So let's find out about friction, and if it is going to act, then in what direction it is going to act. So we just proved that after collision, V prime is equal to 0 and omega prime is equal to 7 radian per second. So therefore, it is a pure rotation motion. It is a pure rotation, and we know that for pure rotation there must be a frictional force. There must be a frictional force that is going to prevent the slipping. That is going to prevent the slipping and keeps the point of contact stationary relative to the ground. Stationary relative to the ground. So from here, one conclusion is sure that friction is going to act. So therefore, option number D is false. It states that no friction is between the ring and the ground. Okay. And now we are going to find out in which direction the friction is going to act. Okay. So for this, we start from that right after the collision. Okay, so thus right after the collision, the ball's impact causes the ring center of mass to decelerate to zero. And also induces a clockwise angular velocity. Therefore, the friction, which for a pure rotation motion should be acting in the opposite direction. Okay, so you can say it will be in the clockwise, in the counterclockwise direction. You can say that. Therefore, for ring to rotate purely without slipping, the frictional force at point of contact must counteract any tendency for the bottom to move leftwards. Okay, at point of contact must counteract any tendency for the bottom of the ring to move leftward. Relative to the ground. Relative to the ground. Okay, because we already said that there is a clockwise angular velocity. Thus, we can say that the frictional force which will be acting between the point of contact and the ground will be in the opposite direction. Okay, so we can say thus frictional force will oppose the tendency of the ring, tendency of the ring's contact point to move right due to clockwise rotation. Due to clockwise rotation. So in order to counteract rather the tendency of the point of contact to move towards the right, the friction will be acting such that it opposes this clockwise rotation. Okay. Therefore, we can say friction acts to the left. Okay. So in the shorter form, we can say that the point of contact will have the tendency to move toward the right. Therefore, the frictional force will try to oppose this movement of the point of contact towards the right. Therefore, the frictional force will be acting towards the left. And we can say the option C is true. C is true. And C is true, so obviously D will be false because it says that no friction will be acting. So we can say D is false. So we have A will be true. Sorry. B will be false. And C will be also true. And D will be false. So this completes the question. Thank you.